Hello everybody. I'm not feeling great today, so here is the lesson for today. So we're getting into the actual Algebra 2 stuff now. So please pay attention, and if you have not already downloaded the graphing calculator, please do so. If you haven't done it yet, go to the announcements February 1st, and the link to put it on your Chromebook will be there. And I promise you it's going to be worth it. It's going to make this a lot easier. You can do some of the stuff in Desmos, but having the graphing calculator will make it much easier. So here we go. So if I asked you 2 to what power is 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's going to be 2 to the 4th power. If I can get my pen to work. Okay, that's going to be 4. And then we know 3 times 3 times 3 is 27, so that's 3 cubed. Now, a little trick here. This one's on the bottom. So let's first think about 64. So 4 to the 3rd power is 64. But since we want the 64 on the bottom, we want it to be negative 3. Now, the last one, as it says here, is tricky. Okay, 10 to what power is 134? Well, if we think about it, 10 squared is 100, and 10 cubed is 1,000. Obviously, our answer has to be between 2 and 3. It's going to be a decimal. It's going to be 2 point something. And if we think logically, 134 is way closer to 100 than 1,000, so it's going to be like 2.1 something. 2.2 maybe, but really small decimal, close to 2. All right, now in this next section, what we did in class for the odd classes, was I actually had everybody try to figure out a pattern. Forget this log stuff. Just look at the numbers 2, 8, and 3, 2, 5, and 22, 3, 81, and 4. And can you rearrange those in a way that makes a true exponential statement? So I'm going to ask you to hit pause and try to figure out yourself. If you want to unpause and listen to the first one and see if you can figure out the pattern for the rest, go ahead and do that. Okay, so if you're back, if you were giving it a shot, looking at 2, 8, and 3, if I said 3 squared, that's 9, 8 to the 3rd is going to be huge. But hey, if I said 2 to the 3rd power, that's 8. Now this next one, if you're back, I could say 5 squared is 25. Over here, 3 to the 4th is 81. Okay, 6 squared is 36. So 6 to the negative 2 is 1 over 36. This next one is tricky because you could say 4 squared is 16. And 2 to the 4th is 16. But if you follow the pattern that we've been doing on the other ones, it's going to be 2 to the 4th. We also know 2 to the 5th is 32. So 2 to the negative 5 is 1 over 32. Not 33, 32. Okay? And we're going to see how that plays into what we're going to be doing here with logs. So if b and x are positive numbers and b is greater than 1, or not, sorry, is not 1, then we have this new statement. Log, like we just had, log b of x equals y, if b to the y equals x. So our exponential form is that thing we've been doing for quite a long time, b to the y equals x. And the new log form is log b for base, of x equals y. And we'll get into what this means. So, if you think about it, x, when we write the variable x, we know it's x to the 1st, so we don't put a 1. We also know it's 1x to the 1st. We don't put a 1 there either. We might in certain circumstances, but generally it's understood that that's a 1. Okay? Same thing here. Log x equals y means log base 10 of x equals y. If there's no number here, assume it's a 10. And I would say write it in, because the common base is 10. All right, so now if you're a Harry Potter fan, like me, and if not, this is the way I like to remember it. What I'm going to do is swish and flick. So I'm going to do that pattern we did over there and come back over the equal sign. So what we did on the previous page was we figured out 2 to the 4th power is 16. So on this one, swish, 3 to the 5th, come back over the equal sign, equals 243. Now, just because it's letters, it's the same thing, and even if the equal sign is on the other side, you can do this. You just swish, so the base, W to the R, and come back over the equal sign. But if the equal sign is on the left, you just have to go a little bit further to get to that Q. Now in this one, notice there is no base, so we put the 10 in there. And then we swish, 10 to the A, that's supposed to be an A, not a 9, equals K. Now, this is the harder part for me. I told you before I struggle with math, and my brain has trouble processing sometimes. And in this case, I have trouble processing going the other way. Swishing and flicking is very easy for me, but going back to a log is hard. So in fact, when I'm going to log form, I can just write in log right away, because I know it's going to have the word log, because it says write it in log form. Now, remember, we called this little 2 here the base. On the previous page, we called 10 the common base. So if we think about an exponent, exponential form, 7 is the base. So that goes down here. It goes from being a big 7 to a little 7. And then what I do is I draw my equal sign in, and I actually draw the arrows in to keep my brain straight and swish and flick. So I say 7 to the power of 2 equals 49. So I would suggest you do this at the beginning just so you get used to this. So what's my base? 1/4. I write my equal sign in, and I swish and flick. So 1/4 to the 3rd power is 1/64. Okay, what's my base here? It's backwards, equal sign's on the left, but my base is M. So I swish and flick over the equal sign. So M to the T equals P. What's my base here? Z. Swish and flick. Z to the math equals fun. And that's the basic concept of logs. Writing them and converting back and forth. It's really actually easy. Now, for the calculator part, here's why I said it's going to make your life a lot easier. If you get the graphing calculator, turn it on, and get it to work, hopefully. Okay? And what you're going to do is, you're going to hit the math key. And you're going to go, well, technically down a lot. And you go here to A, where it says log base. And that allows you to put this little 3 in right here. And then you arrow over and put this 81 right in here. And hit enter. Now, obviously, if this is unknown, we could swish and flick and rewrite this. 3 to the 4th equals, sorry, my bad, jumped ahead of the answer. And I could say 3 to the x is 81, and use my table or just my math knowledge and say 3 times 3 times 3 times 3 is 81. But if I use my calculator, I can go right there. So when it says evaluate, save yourself time, just go to the calculator. So on this next one, I'm going to hit the math key. And this time I'm just going to go up a few. It's quicker. Hit enter. And I can literally just type in 1 divided by 2. I can also put the decimal 0.5, but we're going to get repeating decimals like 1/3. So you just type in 1/2. 1 divided by 2. And then put 32 here. That's going to be a negative number. Negative 5. Okay. And last but not least, I'm going to hit math. Go up a couple. Hit enter. Now remember, my base is not shown, so it's 10. Okay, so I'm going to put a 10 down here for my base. Maybe. Go inside the parentheses and put 0.01. Enter. And I get -2. Okay? Now, just some vocabulary down here. Exponential functions, like all of our parent functions, have inverses. Remember, inverses are where the x and the y switch. So if a function is 1 to 1, then its inverse will also be a function. Okay? So if I have a function and it's 1 to 1, that function's inverse will also be a function. To do this, we use the horizontal line test to predict. Now, we talked about before that when you have an inverse, the x and y switch. So to find the inverse, algebraically, we switch the x and the y and solve for the new y. Now, this was the last question on your previous unit test, and we've done it in the past. So you start off like this. You just switch the x and the y. And now we're going to solve for this y. How do we get that by itself? Well, first we add 8 to both sides. And then we divide by 3. So that's the inverse. X plus 8 over 3. Okay? So what happens is the log function is the inverse of the exponential function. So let's review real quick. We're going to graph a log here. It's very easy. Okay, and yes, you could use decimals for this, but since you're using the graph calculator, might as well use that and stay with one device. So let's talk about the inverse real quick, which is 2 to the x. Okay, y equals 2 to the x. All right. Now, if you remember, we talked about how exponential functions have a horizontal force field, asymptote, at 0 for the parent function. And it always hits at 0, 1, again, the parent function. And in this case, 2 to the 1 is 2, 2 squared is 4, and our function looked something like this, where the domain was always going left and always going right, negative to positive infinity, and my range bottomed out 0 towards positive infinity high, up to the sky. Okay? So what we're going to do now is, basically, we're just going to enter this in the calculator. So we're going to go to y equals, and I'm going to hit that math key. I'm going to go to log base and hit enter. And I'm going to put the 2 in here and the x in here. And you're going to see what it looks like. Okay? And if I went to my table, I have points here, and I'm just going to put them on the paper over here. So for my log here, basically, I'm going to have 4, 2, 2, 1, 1, 0, and then a bunch of fractional ones. So I'm going to have 4, 2, 2, 1, 1, 0, and here's what it's going to do. And now I have a vertical force field at 0, but this time on the y-axis. And the cool thing about this is it is folded over y equals x. We talked about this earlier in the year. Inverse operations reflect over the line y equals x. So if I could fold it over that dotted line, my piece of paper, my graph, those two would line up on top of each other. Okay? Now, the difference is the domain and range are switched now, which we talked about. X and Y switch. Domain is the X values, range is the Y values. So before, my domain was negative infinity to positive infinity, and my range was 0 to infinity. Well, this time, my domain, how far left does it go? It hits the force field at 0. How far right does it go? Infinity. Whoops. The range, okay? Now, instead of 0 to infinity, it's going to go forever down and forever up. Before, I had a point, a y-intercept at 0, 1. Now I'm going to have an x-intercept at 1, 0. Again, everything just switching back and forth, x and y. The only thing that stays the same is it's still continuous. That's supposed to be a u. Okay, last one. I'm going to go to my calculator, go to y equals, and I'm actually going to just come in here and change this to 1 divided by 3, which I can do. I can just overwrite it and hit graph. And then I would go to my table, and I would get 9, negative 2, 3, negative 1, of course 1, 0 again. All right, so 9, negative 2, 3, negative 1, and 1, 0. So if we look at that graph, same concept. My force field's still here. The only thing is, it's going the opposite direction because the base is 1/3 instead of 3. So that is it for your introduction into logs. Now, if you go to 7.4 homework in Canvas, it's going to try to take you to quizzes. It does not work. The link is broken. So all you're going to do is the quizzes assignment is actually printed in your homework packet. So you're just going to do it on paper. Okay, take a picture of that and upload that into the submit part of the assignment. Have a good day.